Okay. Let's go. You ready? Let's have a hand for Cyber Revolt, please.
All right. Hello, everyone. I'm Daniel. You might have seen me before. I sometimes speak about open source firmware. And at some point, I also had to start to look into more specific stuff. So this talk here is about the Intel Management Engine, sometimes also known as the Manageability Engine. It always depends on what website you find or what person you ask. You might get either response or both. So let's see. A little disclaimer first. I am not trying to blame Intel for anything they have done or something. This year is not about whether we can trust Intel as a company or any other chip vendor or vendor in general, because I cannot read their minds. I don't know their intentions. What we can only do is see what they put out in the public or what we find in the machines that we buy. And on the other hand, we don't really know that much because, especially with the Intel ME, there is not very much public information. So people try to figure things out. There are forums, there are certain small projects like analysis tools and stuff. But all of these are based on reverse engineering or educated guessing or whatever people could just figure out. And me especially, I don't know very much about it actually. So I'm just here because I'm interested in the field, and at some point there was an event which made me look into it. But more about that later. The agenda for today, I will give a very brief introduction. It will be a very bold introduction though, into the entire field around firmware. Then I will be switching over to the open source firmware stuff we do. I will briefly try to explain the hardware we know as Intel's x86 platforms. Then I will try to give you a motivation to also look into what I've been looking into and tell you what made me look into it. I will give you some entry points for analysis, and eventually we will just get a conclusion and start to think about what we just heard. So for the introduction, who of you in the audience has already done something with microcontrollers? Please raise your hands. Okay, we see lots of hands here. And in fact, we actually have like hundreds or thousands or millions of microcontrollers here, right? So all the lights we see over here, they're ESP8266. That board you see in the middle, there's Arduino, and there is something which I like to call not the network of things, because apparently you just need a network, you don't really need the internet for it. And we can connect all of those devices. We can remotely control them. And I'm now going to show you that what you have in your laptop is actually the very same thing. Now this is lots of bullet points, and I'm very sorry for it. But this gives you a feeling of what we are dealing with here. In your laptop, you have multiple such controllers, which are very similar to the Arduino or ESP microcontrollers that you already know. Some of them are for very, very specific functionality. So everyone knows the USB controllers. We have USB controllers. We have PCI, where other devices are connected. We have GPUs. We have a whole lot more. But the very core, that's what is known as the chipset and the CPU. It can sometimes also be one single chip, like in this graphic here, which I borrowed from Intel. Just adjusted the colors a bit to make it fit with the slides. And here you can see lots of lines connecting all of those controllers. Now there's some other controllers which I also started to look into. They are called the embedded controller, which is an additional microcontroller on your laptop for power management, for controlling the charging circuit. When you connect your charger to your battery, you will see an LED. That's what this device is doing. It might be connected to a keyboard, to your mouse. And there is a very similar concept also for servers. It's called BMC, or Baseboard Management Controller. Its purpose is to remotely control a server so you don't have to actually go to a data center. Imagine you are administrating 5 data centers all across the world. You can literally be in all of them at the same time. So that's why they came up with an interface to remotely control it. And they've made a dedicated chip for it, which is also connected to many devices on the server platform. Then there is one thing you might also have heard about, a so-called TPM, a Trusted Platform Module. And its main purpose is to give you a very small trust anchor from which you can run all of your top-level applications, below which is an operating system, which is actually running after a bootloader, which is actually started from your firmware, which is actually loaded from your chipset. And that's how deep the rabbit hole goes. Now let's look at open source projects. We have projects for all sorts of features around the CPU. The CPU, before your laptop can even start up, it has to be initialized. It also has to know the RAM. When you boot up a machine, it doesn't yet really know anything about RAM. That's what the Core Boot project is doing. Now today we have a bit of a problem because we don't have enough information to actually program Core Boot for modern machines. So there is a different approach now. You know the UEFI, or Unified Extensible Firmware Interface. It's a bit of a different approach also to initialize hardware, but also to hand over to an operating system. But the thing is, there's lots of drivers in there and stuff, so we want to replace that with a Linux kernel. That's what the Linux boot approach is doing. There are different implementations, there is heads, there is uroot, and that's how we can start modern machines with a bit more knowledge. For embedded controllers, we have the projects from Google for the Chromebooks. There's lots of open source implementations, but they only apply to very specific hardware. You can find all of the stuff on the web, of course. And then System76 is also currently working in that field for their laptops. And eventually, for the BMCs I just introduced you to, there's also 2 projects. There is the OpenBMC project and the uroot project. Okay, so that's how far we are. But that's not what I'm talking about today. I'm talking about something else. And that's why we have to take a closer look at Intel's x86 hardware. This here is an example of a platform which has a dedicated chipset and a processor. This is also a graphic I borrowed from Intel once again. It shows you where all of those peripherals are connected. So again, we have USB, we have Ethernet, but there is more to it actually. And you can clearly see that this chipset here, it's quite a large box. And there is a reason for it, because that's where actually most of the chips are connecting. That's why Intel calls it the Platform Controller Hub, or PCH for short. Now let's look closer at the Denverton platform. Denverton is one of those model names for the platforms. Intel always comes up with these names. And here we have a very brief summary of what peripherals we have. And if you look very closely, in the upper right corner, there is 2 so-called engines mentioned. One of them is the innovation engine. The other one is the management engine, which we're dealing with today. The innovation engine has a very brief description. It says it's something about innovation, it's something about firmware, but actually I have not yet found any use for it, but it's there in your hardware. So if you have a Dan Virtual chip in your laptop or wherever you might find it, you have some features there, but I don't know what they are for. Okay, so let's look at the management engine today. Because the thing is, hardware is evolving. The management engine today is not the management engine from a few years ago. So with new hardware, we get different chips over time. They are attached to different other peripherals over time, and they're given different purposes. So basically, the ME itself is just a microcontroller, like Arduino, and it's part of your chipset. If you have a combined chipset and main processor, it's in that one single chip, but that's where it is. But that's not where it started. It actually started as the so-called active management technology. The idea was that you could remotely control a device and provision it, just like what I described you as the baseboard management controller for servers. It's the same thing, but for, let's say, laptops, desktop PCs. Imagine you're running a very huge company and you have hundreds of devices to maintain. Now you have this BMC thingy for servers and this thing here for your desktop devices. Now the question is, why is it actually connected to all of those peripherals? First of all, there was a bit of a renaming recently. It's no longer just called the ME, it's called the CSME. Converged Security and Manageability or Management Engine. It can load your firmware and verify it. And with that firmware, we are now talking about the host CPU firmware. That thing that Coreboot can be doing, or what your vendor's UEFI firmware is doing. If that firmware is not as expected, which means it's not signed with a certain key from either Intel or your OEM, the equipment manufacturer, which can be HP or Asus or whatever, then your laptop may not boot. That's a feature. It's a security feature. Now the problem is, if we want to legitimately replace the firmware with our own implementations, we can't do it if this certain feature is activated. It's also known as boot guard. But again, this is not what we're talking about today. I want to look at something else. This here is how your machine boots up. On the left hand, you see the flow I just described to you, what the ME is doing. You press the power button on your machine. The ME is coming up. It's initializing itself first with its own firmware. That's the RBE phase. A bit more about that later. Then there is a bring up phase, which hands over to the ME operating system if that version of your ME actually has an operating system, which is not necessarily the case. It will reset the CPU itself. It will trigger the firmware on the CPU to start. That's where Coreboot could take over, or your vendor's UEFI firmware. It loads some microcode updates. It comes to the initialization phase, where you get the RAM and the CPU, and eventually all the features you have in your chipset itself, until you can boot your host operating system. Now at the same time, there's two more chips even being powered on. One is the PMC, the power management controller, which also gets some updates or patches from the ME firmware. And the EC, the embedded controller, I already described you, which is just running in parallel. But in fact, these are all connected to each other. And here are some of the features summarized which we have in ME. So the active management technology is implemented, for example, in the Linux kernel. There is a driver for it. It can do hardware monitoring. Like it can monitor if your chips are overheating. It can have other sensors connected to it. It can do power control. That's why I just described to you, just like a BMC. You can power cycle your system through it. You could update your operating system out of band. So not like using apt-get upgrade or something. No, instead you would just do it from outside. So you could reformat an entire disk, replace it with a new image. You have a bit of storage, and you even have a proxy for a keyboard and mouse and the video interface. So it's like VNC, literally. That's what we know from the public documentation. Now, the interface that is implemented in the Linux kernel has been extended a bit. Now we have a dedicated chip, which was pulled out of the ME, the ISH, or Integrated Sensor Hub. It just does the very basic things I just described to you about sensors, just in a dedicated chip. That's a good development, actually, because now we don't have a single point of failure which has everything. We have a single point of failure which has everything but this part. There is BIOS extensions. In your host firmware, there can also be certain libraries or drivers which are connecting to the ME. You can control the ME through it. If you have a business laptop, you might be running the corporate version of the ME firmware.